Now we need to find the values of the expression without using a calculator. So we apply the law of indexes. Use question number 6b as an example. We will have 4 to the power negative 4 times 1 over 2 to the power negative 4. To do this question, we have two ways. We can change the expression to the same base and then we can solve it, or we can change it into the same index. I hope you still remember. The first one is if I have a to the power m times a to the power n, I can have a to the power m plus n. That is with the same base. Another one is if I have a to the power n, b to the power n, I can take out the index with a, b whole thing to the power n. So to do this question, you can use either ways. Okay. So suppose I change to the same base, and then I hope you remember 4, you can change it to base 2. Then you will have 2 square, whole thing to the power negative 4. And for 1 over 2, you can change it to 2 to the power negative 1. So 2 to the power negative 1 to the power negative 4. And then we will have 2 to the power negative 8 times 2 to the power 4. So answer becomes 2 to the power negative 4. Negative 8 plus 4 is negative 4. And answer 1 over 16. Or I just said you may use another way. This one, a to the power n, b to the power n equals to a to b to the power n. Because we have the same index for this one, so I can make it like 4 times 1 over 2 whole thing to the power negative 4. And then 2 and 4 you simplify, becomes 2 to the power negative 4. So the answer also 1 over 16. Okay. And other questions, number 16. 8 to the power negative 2 times 2 to the power 5 again. So based on what I mentioned, these two, we try to change to the same base or the same index. So negative 2 and 5, difficult to change to the same index, but to change in the same base, I can change 8 to 2 cube. So 2 to the power 3 to the power negative 2 times 2 to the power 5. That's why we will have 2 to the power negative 6 times 2 to the power 5. So negative 6 plus 5 remains negative 1. So the answer will be 1 over 2. Okay, so we do not need to use calculator. We just change into the same base. And I will use question number 17 as example as well. So 17a, 20 to the power negative 6 times 4 over 5 to the power negative 1 to the power 5. To handle this, you may think 20, how can I change 20 to same base or same index? And any relationship between 20 and 4 and 5. So if you are clear enough, then you will remember 20 actually comes from 4 times 5. Actually, I can change it to 4 times 5 whole thing to the power negative 6. And this one, I can distribute the 5, the index 5 back into the bracket, so we will have 4 to the power 5 over 5 to the power negative 5. And then what's next? The negative 6 can put back, so we'll have 4 to the power negative 6 times 5 to the power negative 6 times 4 to the power 5 over 5 to the power negative 5. And then what's next? We try to rearrange the terms. If the terms have negative index, now we have negative index, this one, that is in the numerator actually. So I put it back to the denominator, so I have 4 to the power 6, 5 to the power 6, and 4 to the power 5 remains in the numerator, but this 5 to the power negative 5 will go up to the numerator, so it becomes 5 to the power 5. Afterwards, you simplify with the same terms. Okay, they are the same a's, so I can simplify them. These two with the same base, so I can simplify this. So I will have 4 remaining in the denominator and 5 remaining in the numerator. The denominator nothing, so it becomes 1. So the answer becomes 1 over 20. That is for question number 17a. You just make 20 into 4 times 5 and then put back the index, and then for any negative index you swap the position. Okay, then you will find out the answer. 17b. So again 4 and 9, 2 and 3. But this is a negative index for a fraction, so I can quickly swap the position and then make it to cube first. And then next, I try to think of any relationship between 9, 4, 2, and 3. So I hope you know 9 is a square of 3, 4 is a square of 2. So I can change it to 3 square over 2 square to the power 3. And then this one I can separate into -1 to the power 5 and 2 over 3 to the power 5. What's next will become 3 to the power 6, 2 to the power 6 as well. And this one, -1 to the power 5 is -1, and then 2 to the power 5 over 3 to the power 5. They multiply with each other. So -1 outside, and then we'll have 3 to the power 6 in the numerator, 3 to the power 5 in the denominator. 2 to the power 5 in the numerator, 2 to the power 6 in the denominator. And then, so after simplifying, 3 remains in the numerator and 2 remains in the denominator, and this -1 times the term will becomes negative. So answer -3 over 2.